Okay, so we're going to go back to the tasting, non-tasting pedigree. And let's just kind of make a key. So this pedigree is going to have both genotype and phenotype. And for our genotype, NT is going to represent non-taster, okay? And T is going to represent taster. And as before, square equals male, circle equals female. Okay? So here's what we're going to do. We're going to think of all of the possible combinations and see if those combinations could come out with the outcome that the pedigree suggests. All right? So let's start here. We've got a phenotype of non-tasting PTC. Remember, phenotype is the expressed trait. And in this case, the trait is the ability to taste PTC. So the variation that this male has is non-tasting. And as we discussed in class, non-tasting is recessive and tasting is dominant. So the only possible combination of alleles that could give non-tasting would be to have both sets of alleles be NT. Okay? Then you've got another non-taster who's a female. So non-taster, NT, and female, NT, non-taster, right? And what you want to do is figure out what all the possible allele combinations are that their offspring could inherit. And to remind you, in the pedigree system, the line comes down, and the ones who are actually connected with an extended vertical line are the offspring. Okay? So now you've got NT here and NT here. So the only possible combination you could have for these offspring, taking one allele from dad and one from mom, would be NT. So for all three of the offspring, I'm going to go ahead and fill in NT. All right? And as you can see, that matches what's going on with the phenotype. NT alleles would give you a non-tasting phenotype. Okay? Now here, they've got a taster. Okay? Here, it says phenotype taster, but we don't know the genotype. So let's think this through. If we got T is dominant, you could take an NT from here and a T from here and get a taster, right? But it also could work if you had an NT. So if you had someone who's hybrid for this trait and had both alleles, both types of alleles, you could still take an NT from here and a T from here. So this one we're not really sure about the genotype, only the phenotype. But down here, the tasting coming with one parent that's a non-taster, it would have to be NT. And I'm going to put a little star by this one because we're going to come back to it. Now let's come up here. We don't know about the parents of this one. We only know that it's a taster, so it could be TT or it could be TNT. We don't know their parents, so we don't know what alleles the parents had to donate, but these both would give taster outcome. This one is a non-taster. NT. Okay? So you want to get a taster here, so you're going to get an NT from mom and a T from dad. Wherever it came from, you could still get a T from dad. So that could give you a taster offspring here. Now this one, a non-taster, could this happen? Yeah, you've got two non-taster alleles here. Take a non-taster from there, and then a non-taster from here. Okay? And that NT combination is going to give you a non-taster. Now, I'm going to put a star on this one too. It says, did the model work? Yes. Yes. Were there any parts of the pedigree that the model could not help you explain? Circle these and describe what the model couldn't explain. So I kind of made stars next to those. These two, we were unable to tell what the genotype was because they're a taster, and since that's the dominant trait, it could be that they had both dominant alleles, T and T, or it could be that they have a recessive NT and a T. So number 7 and number 3, unsure of genotype, parent information not available. All right, and that's how you fill your pedigree. Good job. 3-generation pedigree.